In today's lesson, we are going to be looking at graphing quadratics from factored form. So in our previous lessons, we've looked at transformations, we've looked at sketching graphs using transformations or sketching graphs with multiple transformations. Essentially, we are graphing the vertex form of a quadratic. In today's lesson, we're going to be looking at graphing a quadratic in factored form. So it's still going to be a quadratic, it's just going to be with a little bit, it's going to be from a different representation. So we're going to be using different things than the transformations we've looked at. So this will probably be a little bit of review from grade 10. So just a little bit of review in general. Right? The factored form of a quadratic is f of x is equal to ax minus r times x minus s. And the key things here are your r and your s values. And these are key because they are the x-intercepts. So r and s represents the x-intercepts. And they're also known as roots or zeros. So your zeros, your roots, your x-intercepts, they all mean the same thing. And that is what the r and s represent in the factored form. So that's what's different about factored form. It gives us the x-intercepts compared to the vertex form, which gives us the vertex. One thing to keep in mind, the r and s are opposite of what we see in the equation. And that is due to this minus being included or part of this general form or this general equation. Very similar to the vertex form or the transformations where the h value was the opposite. The same idea applies here. So once we find the x-intercepts, or once we get the x-intercepts from this factored form or from the equation of the function, we can use the x-intercepts to find the vertex. Right? So we are still going to find the vertex using the information that's given to us. Now the vertex is halfway between the r and the s. Right? Because we think of the axis of symmetry, that is a vertical line that goes through the vertex, but it also cuts our parabola in half. So if I know two x-intercepts, I just have to find the halfway point between them, and I'll find where that axis of symmetry is, or where the x value of our vertex is. So we're going to basically get all of this information through calculations involving our x-intercepts. So the first example, we want to determine the following characteristics for the given functions. Right, so we're given a quadratic function in factored form, f of x is equal to x plus 3 and times x plus 5. Now here what we want to do is we want to find our x-intercepts. So going back to that general form, it basically says the r and the s value, these two values are the x-intercepts. However, remember the equation was x minus r times x minus s. Because we see a positive, it's actually going to be the opposite. So our x-intercepts are going to be negative 3 and 0, and negative 5 and 0. So remember the x-intercepts, they're a point, right? They're a position on our graph where the y value is 0. So that's why we have these points, negative 3, 0, and negative 5, 0. You could just say the x-intercepts are negative 3 and negative 5 and just don't put them in brackets to indicate that it's two different values and not one, or you can write them as such. To find our vertex, right? If our vertex is in the middle of our function, we want to be able to determine the middle, or we want to find the middle. So how we do that, negative 3 plus negative 5, so we add our two x-intercepts, and divide by 2. So negative 3 plus negative 5 is negative 8, divided by 2 is negative 4. So therefore, the axis of symmetry is x equals negative 4. Now one thing to keep in mind, when we looked at this when we looked at transformations, the x value for the axis of symmetry is also the x value of our vertex. So right now, for our vertex, I know the vertex is going to be the point negative 4 and then something for y. how we find that value, let me say x equals, how we find that value is we take this -4 and plug it back into the equation that was given to us. So if I take f at x equals x plus 3 times x plus 5, essentially what we're going to be doing is finding the value of the function when x is equal to -4, or f at -4, which will equal -4 plus 3, so going back to that function notation, times -4 plus 5. -4 plus 3 is -1. -4 plus 5 is +1. -1 times +1 is -1. Oops. -1. So we now found the y value of our vertex. So our vertex is going to be -4, -1. So now we have our vertex as well as the x-intercepts for this given function. We can go through and do another example, right? So here we have y is equal to -3 times x minus 3 times x plus 3. Again, for our x-intercepts, we're taking them right from the equation, the two values that are going to be in the brackets with x. So we have, in this case, the x-intercepts, we have +3, 0. Right? So again, opposite of what we see. And we have -1, 0. Again, opposite of what we see. For our vertex, we're going to find the x value first. We're going to add our two numbers together, 3 plus -1, and we're going to divide that by 2 to find the middle value. 3 plus -1 is 2, divided by 2 equals 1. So therefore, the axis of symmetry is x is equal to 1, and I know the vertex is going to be 1 and then a value. To find that value, I'm basically going to take it and plug it in for x in our function. So I'm just going to replace x, so -3 times 1 minus 3 times 3 plus 1. Y is equal to -3 times -2 times +4. Oh wait, no, not +4. I wrote the wrong thing. +2. Now we're going to go through and multiply. -3 times -2 is 12. Times 2 is, or no, not, it's not, it's times 6. Or -3 times -2 is 6. Times 2 is 12. Kind of jumping ahead of myself there. So now I know that the vertex is going to be 1, 12. So again, I have my x-intercepts and I have my vertex for this quadratic function. Now this should be a little bit of a review from grade 10, finding the x-intercepts, finding the vertex from that, but we're going to continue on. So now we have a function. We want to identify the key features of our graph. So basically just to get an idea of what it looks like or where these values are, we want to find our key components. Right? So the similar ones we found, we have our x-intercepts here and here, and it looks like the x-intercepts are going to be 2.5 or -2.5. We have -2.5 and 0. And on the other end, we have +1.5 and 0. So those are our two x-intercepts, and we can see a vertex down here at, looks like -0.5 and -16. So again, that's just looking at finding the different components, the same components we were looking for, the same characteristics we were looking for, but now seeing them in a graph. We can see that given those 3 points, we could sketch a fairly good representation of what our quadratic looks like. And that's basically going to be the whole goal for this lesson, is finding the x-intercepts, finding the vertex, and then using that to sketch. So zeros, again, going back to zeros, we're going to work through it step by step to find this information. And we just kind of looked at it anyways, but we're going to go through and go step by step. So what is a zero, right? Zero is different definitions, but where the, say the function crosses the x-axis. Another way you could say it, call it the x-intercepts or roots. Right? So or in another description we can say, just because it ties into the definition, it's going to be the point, or not the point, we'll say when y is 0. So when y is 0, the x value is our is the 0 that we're looking for. Right? So when we multiply together, the product is 0, and both or one must be 0. So in this case, if we have an a times b equals 0, either a equals 0 or b or both. So we're going to use that idea to help us come up with our zeros. Now we're going to do it a little bit more mathematical than compared to what we just did, because some of them might not be as easy. The first one, f of x is equal to x minus 5 times x plus 4. This one is relatively easy. I'm just going to show you how you can find it if you do get stuck or you do forget that this happens to be the x-intercept. So for the x-intercept for y to equal 0 or the function to equal 0, either this whole bracket here has to equal 0 or this whole bracket here, or both. So in this case, what we're going to do is we're going to take each bracket and set it equal to 0. So x minus 5 equals 0, x equals positive 5. Bring that negative over, it becomes positive. On the other side, we have x plus 4 equals 0. Bring that positive 4 over, we have x is equal to negative 4. So that means our two x-intercepts, or the two zeros or the two roots, are going to be 5, negative 4. I'm going to do the same thing for the next one. Take each bracket, 2x plus 5, set it equal to 0. 2x minus 3 equals 0 for the other bracket. And what's different here is now we're going to have to solve a little bit more, because it's not as easy as just looking at the function and picking out our x-intercepts. So I move the 5 over. I get 2x is equal to negative 5. Divide both sides by 2. I get x is equal to negative 5 over 2, or negative 2.5. Same thing on the other side. We move the 3 over. We get 2x is equal to 3. Divide both sides by 2, and we get x is equal to 1.5. So that tells us that our two x-intercepts are going to be at 1.5 and negative 5 over 2, or negative 2.5. Again, it's a nice decimal, so feel free to use a decimal if you'd like. You don't have to leave it as a fraction. The next step is the axis of symmetry. And the axis of symmetry, if we forget, is the center line down which the parabola can be folded symmetrically. So again, it's kind of that imaginary middle line that cuts our parabola in half. And if we know the zeros, how can we find the axis of symmetry? How can we find that middle value? And we did look at this when we looked at our review, but the axis of symmetry is basically the middle. So if I have my two zeros to find the middle, I add the x-intercepts and divide by 2. So if I add my two x-intercepts and divide by 2, I will find our axis of symmetry. So if I look at the first one, x minus 5 and x plus 4, we did mention that we had negative 4 and positive 5 as our two x-intercepts. So what we could do is we could say, for the axis of symmetry, AOS, we know from our transformations that it's going to be x is equal to. So x is equal to, and we're going to have negative 4 plus 5 divided by 2, we have 1 over 2. Negative 4 plus 5 is positive 1, divided by 2 is 1 over 2, or 0.5. So that means that we have an imaginary line going through right here. So that imaginary line cuts our parabola in half, and it's also halfway in between my two x-intercepts. So the same thing is going to apply for the next one. Again, we could find our x-intercepts. We could go through and look. We did mention in the previous one we had 1.5 and negative 2.5. So again, our axis of symmetry, our x value is going to be negative 2.5 plus 1.5. And we're going to divide that by 2. Here we get negative 1 on top divided by 2, or negative 0.5, which if we go through and sketch, we can see that it is directly in the middle and goes through the vertex, or it's halfway between our x-intercepts. Lastly is the maximum or the minimum. So what is the maximum slash minimum? Well, the maximum or minimum is the highest or lowest value of the function. In other words, and as well, it is the value of the function at the axis of symmetry. So if we know the axis of symmetry, how can we find the maximum or minimum? And we were doing this because this is just basically another way of saying the value of y at the axis of symmetry. So if I know the axis of symmetry, or if I know an x value, how do I find the y value? Right? And what we can do is we can substitute. We can substitute the x value or the axis of symmetry into the equation. So going back to the same two functions that we were looking at, on the first one we had an axis of symmetry of, if I scroll back, 0.5. And in the second one I had an axis of symmetry of, I think it was negative 0.5. So all that we're going to do to find the y value, or the maximum or minimum, is plug our x value or the axis of symmetry into our function. 0.5 minus 5 times 0.5 plus 5. We have negative 4.5 times plus 4 plus times 4.5. So if I go through and calculate this, then I multiply these two numbers together, and we end up with negative 220.25. So that means that the maximum, or the minimum value is negative 20.25. And if you're not sure how I determined it was a minimum, right, if I look at my a value front, what sign is it? Right. So in this case, the sign is positive, so that means that the minimum, or this y value is the minimum because it opens up. So that means my vertex is going to be at the bottom, my lowest point. For the next one, same idea, right? F at negative 0.5 is equal to 2, or is equal to, 2 times 0.5 plus 5 times 2 times negative 0.5 minus 3. I'm going to go through and calculate. We have -1 plus 5 times -1 minus 3. We have +4 times -4, or -16. So therefore, my value tells me the maximum or minimum. And it is a minimum, again in this case, because if I look at the a value up here, there is no a value, or it's an a value of 1, which means it's positive, which means it's a minimum because it opens up. So in summary, what do we have to do with a factored form quadratic to be able to graph it? So the first thing we have to do is identify the roots, or you could say the zeros, or the x-intercepts. From the function, that'd be r0 and s0. Once we identify the roots, or the zeros, the x-intercepts, next we have to find the axis of symmetry. And the way we do that is we add the zeros, or the x values, and then we divide by 2. Once we get the axis of symmetry, the next step then is to substitute. So we have to substitute, and how we substitute, we plug the axis of symmetry into the equation for x, and then we find y. We find the y, which is the y value of the vertex, which is also the maximum or minimum, depending on which way our graph is opening. So one example, let's go through and practice. We want to graph this function. So the first thing I need to do is I need to find my x-intercepts. So I'm going to set each bracket equal to 0. Now I don't need to do anything with that -5. That's just in the front. That doesn't affect what the x-intercepts are. Right, so I set the equal to 0, -4, x is equal to -3, x is equal to 3/4. So that is one x-intercept. Not the nicest values, but that is the x-intercept. The next one, 2x plus 1. 2x is on the one side, -1 is on the other. Divide both sides by x, I get x is equal to -1/2. So now I have my two x-intercepts. So I can actually go through and plot those if you want. Or if we want, -1/2 is here, 3/4 is here. Now, it's a little bit hard to see where the middle is. So because they're not nice numbers, we can actually go through and calculate the axis of symmetry, which is just our two values. So 0.75 plus -1/2, or just -0.5, and then divide that by 2. We get 0.25 divided by 2, we get 0.125. So that's our axis of symmetry. That means at 1.25, so somewhere about, we'll say here, maybe I'll draw my imaginary line, maybe somewhere around there. Again, this one will be as accurate just because of the values. But now I have my axis of symmetry. I can find the y value, or the maximum or minimum, by plugging in the axis of symmetry into this equation. So f of x is equal to 0.5 times 3 minus 4x times 2x plus 1. I now know an x value of 0.125. So I'm going to find the function at 0.125, which will equal 0.5 times 3 minus 4 times 0.125 times 2 times 0.125 plus 1. All I did was substitute these values in. I get 0.5 times 2.5 times 1.25. And when we go through and calculate all of this, the function at 0.125 is going to equal 1.5625. So that is the final answer. That means our vertex is going to be, our vertex is going to be at 1.25, so somewhere along this red line, and 1.56, right somewhere about there. Probably a little bit closer because maybe we can tell by looking at it, doesn't look quite even. And that's all we need to do. So maybe a little bit less steps in terms of the quadratic being a transformation, left, right, up, down, stretch and press. So it might be a little bit easier to sketch a quadratic in factored form, but please make sure you know how to do both types. You're not going to need to know it for this lesson or the practice, but down the line, it will be helpful to know which one's easier.